All right, adult school, physical science. Welcome to week 7. So next week marks our halfway point to the semester, so it goes pretty quick. Tonight's lecture is going to be on energy. It is a term that we hear, talked about quite a bit, loosely, like, I don't have any energy today, or those kids have too much energy and stuff like that. But we never really take the time to think about what it means or how energy can be transferred or converted, because energy, much like matter, is never lost. It is just converted from one form to another. And that's what we want to look at today. So from our Canvas page, if you click on our class, our physical science class, at the bottom here is the week 7 module. Remember last week we didn't have a formal class. I gave you that week to catch up. A lot of people took advantage of that, which is great. And some people even already have week 7's work done, which is spectacular. Like, that's the way to do it. Just get it cranked out, and then the rest of the week is yours. So if you click on the week 7 module, first and foremost, you're going to see the discussion board here. Discussion boards are 10% of the grade, so they are very important, and you want to make sure that you are doing them. So if you click on this one, it's just on energy, and you'll see how quick and easy it is. Just 2 questions based off of this video. This video is like 3 minutes long. It's a quick little interesting video. Answer the 2 questions, and you're good to go. So let me hop back to the other portions of our unit here, or a module for week 7. This will link out to CK12. So you just click on that and it'll take you right here to week 7 energy. And I'll get to this in just a second. Let me just finish up on the stuff that was on the module. And so this link, or this page right here, will just be a link to the PowerPoint that does not have the lecture attached to it. It's just basically just the PowerPoint as a website, and you can scroll through and sort of get extra notes if you need to go over any other sections. All right, so let me hop back. And so now when you click from the link out to CK12, you're going to come across this. And once you hit week 7 energy, you'll see all of your topics here, and then the week's final quiz. You'll see this week there's not that many topics, which is really good. It should be a quick week. A couple people have said like they're confused on how to do the assignments, so pay attention to this part and it'll help you get through it. If I click on energy, it gives me an article to read, it gives me my adaptive practice, and it gives me 4 videos. Now, it is up to you, whatever order you want to do this in. Say you watched the lecture and you're like, I don't quite get everything, so I want to watch a few. This is going to be a set of videos that will help you understand the unit a little bit more, make a little more sense. If you go to the read portion, open it on up, and I took a lot of stuff for tonight's lecture right out of this, so it'll hopefully clarify some things. So it defines energy for us, the ability to move matter, change matter, the ability to do work. And then as you read through it, it'll define it. It'll give you examples. It'll tell you the different forms. It'll give you videos to watch. And so all that is meant to do is to prepare you for when you get to the adaptive practice. Now, when you get there, this is the meat of the assignment, if you will. Like, each adaptive practice gets you prepared for the quiz, and they are a required portion. So I'm going to go in and do my adaptive practice. So say I've watched the lecture, I've read the little articles, I've watched the videos, I feel comfortable enough to do it, and it's going to make me get 10 of these correct, with some of which I may see again on the quiz, like a little hint. I don't know why it's not giving me a question here. There we go. So blank is defined in science as the ability to move matter or change matter in some other way. Now, I will know from both the lecture and the stuff I've read before that this is just simply energy. Check it. Yay, I'm good to go. I have 2 out of 10. Once you get to 10, it'll let you move on to the next section. Okay? And then you'll go through, let me get rid of this. You'll go through all of that. And then you'll do that for each section, and then you'll have a final quiz at the end. So that's how you get those units done, or these assignments done. So a lot of people are sort of picking up the pace on it, which is great. Don't let this get too far, or don't get behind this too far, otherwise it'll be hard to catch up. All right, so let's hop into our lecture for tonight. So we're going to talk about energy. And like we said, it's a term we use a lot, but we really want to focus in on what it is. So simply, I mean, you can use the definition that was on CK12, or you can use this definition as well. It's the ability to do work. So if you have energy, you can get work done. If you don't have energy, you can't get work done. And now work is defined in many different ways in physics that we're not going to get into. So here are some various forms of it. There's gravitational, potential, kinetic, mechanical, chemical, electrical, electromagnetic, thermal, sound, and nuclear. So we have a bunch of different forms of energy that we want to get into. We're going to hone in on the potential and kinetic energies for our lecture tonight. So kinetic energy, this term kinetics, there's a whole field in physics based off of it. It's just motion. So I have the definition over here. So the definition of kinetic is just pertaining to motion or caused by motion. So if we have kinetic energy is the energy of moving matter. So matter that is in motion, matter that is moving about, is kinetic energy. So anything that is moving has kinetic energy, and the atoms in matter, from the stars to outer space to the small stuff, all of it that is moving has kinetic energy. So things with kinetic energy can do work. For example, they have it here, the spinning saw blade. This is doing work against the metal. This guy is doing work in his motion on the motorcycle. As water flows through the hydroelectric dam on the right here, it spins turbines, which creates energy. And so the key with all of this is that kinetic energy is about the energy of motion. So if something is in motion, it has kinetic energy. So say if you were driving in your car, you in the car have kinetic energy. The example I'm going to show you right now is just based off of a baseball, because we can calculate the kinetic energy of anything using this formula right here, which is that kinetic energy is equal to half of the mass times the velocity squared. So it sounds kind of weird, but let's focus in on the baseball here. So a well-hit baseball can travel in excess of 100 miles an hour. So it can come off the bat really quickly. Roughly, that's about 44 meters per second. I just converted it over to have everything in standard units. So a typical baseball weighs about 145 grams. And so we can easily find the kinetic energy within a baseball traveling 100 miles an hour. So maybe this was thrown, maybe this was hit off the bat, but if the baseball is traveling 100 miles an hour, I take that formula, and so I say half of the mass, so it'd be 1/2 of the 145 grams, times the velocity, which is 44 meters per second, and I square that. So if I do that, I get 72.5 times 1,936. Those two together give me 140,360 grams times meters squared over seconds squared. Now that translates into, so the energy is translated into watts. You might be familiar with that. But so the energy that this traveling baseball has going 100 miles an hour can power a refrigerator for almost a month, which shows you the energy that is stored within moving objects. It's pretty intense. All right. So we also want to talk about potential energy. So with potential energy, this is energy that is being stored. So you are not in motion whatsoever, but is the energy that an object has within it. So oftentimes the person or the object has potential energy because of their position. So if we look at the little bookshelf on the left here, everything that is on here has potential energy. Now the amount of energy it has is kind of dependent on how high it is above the floor. Because as this little jar is sitting right here, there's no kinetic energy, it's not moving, but it has potential energy. Because if it fell off, then that energy that was potential is converted into kinetic energy because it is now in motion. Same thing with this little bubble figure here on the half pipe. When he is just waiting, or she, I don't know who this is, just some weird amorphous blob. While they're waiting to go down that half pipe, they have potential energy. They are not in motion, so they are not converting energy one way to another. They just have stored potential energy based off of their position. Now, once the little skateboarder pushes themselves down into that ramp and they start going back and forth, then they have kinetic energy of moving back and forth. And we can find that energy if we wanted to use that same formula, the 1/2 the mass times velocity squared. So potential energy is the energy that you do have, but are not using at the moment. So as I'm sitting here, even though, so I'm sitting here and it doesn't look like I'm moving or anything like that. So I'm not using kinetic energy, but I have potential energy. And even right now, as I'm talking, I'm converting some of that potential energy into sound, into motion, And that does get converted into a kinetic and sound and thermal energy because I'll heat up my body as I go through these motions, if you will. So one type of potential energy is gravitational potential energy. And this is energy due to the position of an object above Earth's surface. So they have this, like a diver on a diving board. They have this person or this gymnast on a pommel horse. And you can see she's, doing this really weird position, and or I shouldn't say weird, but impressive. And at the same time, Earth's gravity is trying to pull her down towards that bar, pull her down towards the Earth. So we say she has gravitational potential energy because gravity is going to try and pull her down to convert that potential energy over into kinetic energy. So on the right here, with coconuts in the tree, all those coconuts hanging up there have potential energy. They have gravitational potential energy because once they fall off of there, gravity is going to pull them down to the Earth at a certain speed, and then that potential energy is converted into kinetics. So that is one form of potential energy, that gravitational, so just due to the Earth's gravitational pull. Now, another type of potential energy is elastic potential energy. So these are two great examples. This little kid who's about to fire a slingshot at somebody, I don't know. They're using elastic potential energy of the rubber band holding on to the slingshot. So as the kid winds up and pulls that back, they are building elastic potential energy until they let it go, and then all of it's transferred into kinetic energy. Same thing with the little hair scrunchies on the left. As they don't have any of that elastic potential energy. But once you stretch them out, their desire to go back to their original shape is what builds up the elastic potential energy within them. All right, so a couple other forms. There's chemical potential energy. So I have this little example right here of chemical bonds. So it's a little bonded atom. We could call this methane. This could be a carbon atom and 4 hydrogens attached to it. But within these bonds is energy that is stored up. Now, if those bonds are broken, that energy is released, but it is not released until it's broken. So that's why we still call it potential, because that has not been released yet. And then lastly, nuclear. So within each of these atoms, there's a nucleus. We talked about this a couple of weeks ago. Within that nucleus, there's a great amount of power. And it's not being used at the moment, so it's still potential. But once we're able to break apart a nucleus, this is what we're looking at in terms of energy being released. Atomic bombs. And that shows you how much energy is within the nucleus of an atom. And so how powerful nuclear potential energy is. All right, so let's just go over some of these. We talked about gravitational, we talked about potential and kinetic energy, as well as chemical and nuclear, but let's talk about a couple other ones. Mechanical energy. That is just, once again, energy of motion. If you're playing guitars, if you're playing drums, if you're, I don't know, what else could you be doing? Oh, if you're hammering something, you are that mechanical energy. You are almost a machine, whether it be like a lever that you're using or a pulley. That is mechanical energy. So that is a type of energy transfer. The kinetics, if I'm playing drums, the kinetics of me moving my hand and hitting each drum is mechanical energy. Electrical energy. This is just almost sounds very obvious, but is a very special type of energy. You can get it from the sun. You can get it from those, we saw the picture before of the turbines with the water going through from the dam. You can build up electrical charges there, along with electromagnetic, meaning that this sort of forms fields that is sort of transferred via like electrons. Like electrical energy is just electrons being transferred back and forth. The electromagnetic is these electric fields or magnetic fields that build up that have their own energy. There's also thermal. So if I stood here and I started to do a bunch of jumping jacks, or if I went on a run and I start to heat up, that kinetic energy. So right now I have potential energy. If I were to run, I'm converting it to kinetic energy. As my body heats up and I start sweating, it is converting into thermal energy. So one of the big things there is that it's not being transferred. It's not being destroyed. That energy is being converted and transferred between different types. Sound energy is another form of energy. As I'm talking to you right now, I'm using my potential energy so that my vocal cords can project this into the microphone, and sound is energy. If you've ever heard like a loud explosion to where you can almost like feel it in your chest, if you've ever been at like a concert and the bass is really high and you can almost feel like your chest vibrating, that's sound energy, and it is very, very powerful. So something simple we could look at here. If I have my hands right now, they have potential energy. Nothing's happening, but their position gives them potential energy. If I bring them together in a clap, I was converting it to kinetics. The air in between heated up as I sort of condensed it in between until my hands heated up. So there was thermal energy there. And then as I clapped and you heard it, there was sound energy. So that potential energy got converted into 3 different types. And so it's pretty impressive. So this is going to link us out to a Prezi on energy conversion. And so that's what it'll go to right now. Perfect. All right, so let me get this up and going. Didn't think it was going to take this long. So just like a few frames of this. So energy conversion, how it goes from one to another. So energy transformation or energy conversion is the process of changing one form to another. So we can harvest light on solar panels to convert into electricity. That's taking electromagnetic energy and converting it into electric energy. So energy is the capacity of a physical system to perform work. So energy exists in several forms that we just saw. There's thermal, kinetic, mechanical, and the law of conservation is fundamental to understanding energy conservation and transfer. We have to know that energy is not created nor destroyed. It is simply transferred. And so here's the types of energy that we talked about. There's a bunch more. And so one of the things I want you to take away from it is the standard unit of energy is measured in what's called joules. So you saw back at the kinetic energy when we went through that formula. At the end, we ended in watts, but watts comes from joules. That is the standard unit of energy is a joule. And so the law of conservation says that the total energy of a system remains constant, so it doesn't change. Though the energy may transform from one form to another, such as like if you play pool, 2 billiard balls colliding, they transfer the momentum, they transfer the energy. And so if we look at the example of the TV here, you have electricity coming in, so the electricity is the input, and then the light coming off of the TV is what you see. You hear the sound coming out of the TV. Those are both forms of energy. And then usually if you feel around your TV, it's a little warmer. That is just heat coming off. So there's thermal energy. Now this energy is being used while this energy is being wasted. So light and sound are being used in this process while heat is being wasted. And that takes away from the overall efficiency of an electrical system. So the electricity that comes in gets converted to both sound, light, and heat. The light and sound are useful. The heat is wasted energy. And so when we're talking about how much energy is wasted as opposed to how much is being used, we call that efficiency. We're not going to calculate it that much, but I wanted to give you the formula for it. So it's useful energy output divided by total energy output. So you want to be very useful so that way you can be efficient. And that's it. So that's our lecture for the week. It's really quick. I didn't want to take too much time with it because you're going to get a lot of that same information as you go through here. So I didn't want to double up too much. But so you'll have this posted on the module. It'll be right down below here, ready to go. I will send out a Zoom link later on. And this way you'll have all these resources to help you get through those CK12 assignments. Please don't ignore these and save them all for like the end. It will not be a good time. You want to make sure that you are working and staying active in the class. Thank you for joining this or watching this too. And I will talk to you later on this evening.